Hello, everybody. Today I am going to go into Unit 2, Section 3. So let me share that screen with you. This is on average atomic mass. Let me make this so you can see that. Okay, so average atomic mass, this is Section 3 of Unit 2. All right, well, first thing we need to talk about is the history of the atomic mass unit, which is abbreviated AMU. The atomic mass unit is the unit of mass used to express atomic and molecular weights of elements. Currently, it is based on carbon-12. Last section, we talked about carbon-12, along with carbon-14 and all that, because, they're isotopes of carbon. But carbon-12 is the most abundant of those isotopes. So it's based on the atomic mass unit on carbon-12. So remember how we said that you write out, just so you remember this from last time, there's your carbon, the C for carbon, that's your atomic mass, atomic number. All right, so 1 AMU, 1 atomic mass unit, is 1/12 the mass of the carbon-12 nucleus. Okay, so more on this later. I just wanted you to understand that when you'll start seeing AMU, and it has to do with the a unit of mass to express, an atom's weight. Okay, so more on that later. But let's just do a little review here of isotopes. Again, we said isotopes were different versions of an element, and the only reason they differ is because of the number of neutrons are different. Protons are the same, electrons are the same, it's just neutrons that are the same. And remember, we said that the atomic mass tells us the neutron and the proton count combined. So this number here is the atomic mass. As you can see, remember how we said when you write out these isotopes, you write out the name of the element followed by its mass number. So you can see here's an isotope of carbon called carbon-13. The 13 represents its atomic mass. And then you have carbon-12. The 12 represents, again, this particular isotopes of carbon's mass. Now, I've written these out in our notation form, so you can see that they both are carbon with the symbol C. And then you can look and see that their atomic numbers are the same. Okay, because remember, we said in isotopes, the proton count does not change. Okay, proton count will be the same for every isotope. It's the neutron count that differs. So again, atomic mass is the combination of the neutrons and the protons added together. It's the entire mass of that nucleus, because remember, protons and neutrons are found in the nucleus of an atom. All right, so for carbon-13, we said it had a mass of 13. Well, how many protons does it have? It has 6. Okay, because that's the atomic number, and that tells us how many protons there are. Now, how do we figure out the number of neutrons? You subtract that proton count from the atomic mass, and what's left over is the neutrons, in this case, 7 neutrons. For this one, carbon-12, we said it had a mass of 12, but look, the atomic number is still 6, which tells us the number of protons, so that does not change for this isotope of carbon. But look at the neutron count. It has changed because, again, the way you figure out neutron count is subtract your proton number, which is the atomic number, from the atomic mass, and what is left over is the neutrons, okay, in this case, 6. So carbon-12 has 1 less neutron than carbon-13. All right, so we have something called percent abundance, and you have atomic masses of an element's isotopes. So what do we know? Elements have different versions of themselves called isotopes. Isotopes of an element have the same number of protons and the same number of electrons, again, as long as it's a neutral stable atom. Isotopes for an element have different masses because they have different number of neutrons. The atomic mass for an element on the periodic table is the average of all known isotopes. Okay, because there's several isotopes for various elements. So the one they put on the periodic table is the average of the known isotopes. And of course, the one that shows up the most in nature will be the one that pretty much makes up the majority of that average, just like any average you do in numbers. All right, so what can we determine? Given various information about an element and its isotopes, such as its atomic mass, the percentage of each isotope present, etc., we can perform calculations. Here's some more math for you guys to learn more information about that element. So again, let's just real quick look at this because we're getting ready to go into a little bit of math. I want to make sure you understand what these numbers mean. So this is aluminum. This is what shows up on the periodic table. Has an atomic number of 13 and an atomic mass of 26.9815. The atomic mass found in the periodic table, this number right here, is the average atomic mass that has been calculated based on all the common isotopes of, in this case, aluminum. Okay, so there's other isotopes out there with different atomic mass numbers, but this one that's showing up on the periodic table is the average of those isotopes. All right, so what does that mean? Maybe if you do some calculations, you'll understand. All right, so here's the formula for average atomic mass. Average atomic mass is equal to, this M here stands for the mass, so the atomic mass of the isotope, and the P stands for the percentage, the percent abundance. How much out of all the isotopes out there does this one make up? Is it 25% of all the isotopes? Is it 10% of all the isotopes? Okay, and then you see this repeated again, but this time it has a subscript of 2. And it's repeated again. This one has a subscript of 3, and it dot, dot, dot means it could keep going on and on and on. Just depends on how many isotopes that you're trying to do the calculation for. Sometimes you'll only be given 2 isotopes. Sometimes you'll be given 3 isotopes. Sometimes you'll be given 4 or more isotopes. It just depends on how many isotopes you're trying to calculate the average atomic mass for as to how far out you carry this formula. Okay, the numbers in the subscripts just represent each isotope. Okay, so you don't get them mixed up. This formula provides spaces for 3 possible isotopes of an element. If you have only 2, then of course you'll drop off this one right here with the M3P3. If you have 4 or more, then you're going to add some, in the formula. All right, so let's look at an example. Trying to determine the average atomic mass for a sample of cesium. Cesium is found on the periodic table. It has the following isotopes in these percent abundances. So 75% of the isotopes are cesium-133. Again, that superscript number next to the symbol represents its atomic mass. And remember, atomic mass tells us the number of protons and the number of neutrons. Okay, neutrons are the important part when you're talking about isotopes. 20% of the isotopes come in the form of cesium-132. 5% comes in the form of cesium-134. So you can kind of see here, you do have one isotope that kind of shows up a lot more than the other ones. Okay. So what is the average atomic mass of cesium? Well, the first thing you got to do is you got to turn in percentages into decimals before you can put them into that formula. Okay, so this is how you would do it. Some people can do it straight in their head, but basically you're going to divide your percent by 100, and that gives you the decimal. Second, you're going to write out your formula. In this case, we have 3 isotopes we're working with, so you're only going to carry the formula out, 3 times. Got to fill in the formula. So remember, the M stands for the mass. So here we have 133 from cesium-133. So you put that there for the first one. And what percentage did it show up? 75%. We said in a decimal that's 0.75. So that's where you get the 0.75 from. Then we look at our next isotope, cesium-132. There's your atomic mass number. We said it's 20% of the time. You put the mass number there. Again, that's what the M stands for, is the mass. You have to multiply that by its percentage. We said 20%. How do you put 20% in a decimal? We said it's 0.20. So multiply 132, the mass, by that percentage. And then the last one, we said 5% of the time you have cesium-134. 134 is the mass. 5% in decimal form is 0.05. And then you just multiply in parentheses first and then add it together. Okay, so there it is, multiplied. Each one of those was multiplied in parentheses, and then we got to add them all together, and the average atomic mass for cesium is 132.85. AMU, again, is atomic mass units. That's just our units that we use for figuring out atomic mass. All right, another example. Find the average atomic mass of silicon given the following isotopes. We have silicon 28 at 92.23%. We have silicon 29 at 4.67%, and we had silicon 30 at 3.10%. Well, what do we say the first thing you had to do? We got to get rid of these percentages and turn them into decimals. Again, if you can't do that in your head, then basically you just divide by 100. It gives you the decimal. We have 3 isotopes, so we're only carrying out the formula 3 times. You're going to fill in the formula, again, with the mass number, 28, and then the percentage. Remember, we turned that into a decimal, so we had to put the decimal in. Okay, that's this one right here. And then we had silicon 29. There's your 29 as your mass. Again, the M stands for mass, and then the P for percent, but we're not using percent. We're using the decimal version. So there's your decimal version of 4.6%. And then last one we said was silicon 30. Put your mass there and multiply that by the decimal form of 3.10%. Okay, so when you do those multiplication parts within the parentheses, that's what you ended up with. And then we have to add those together to give us our average atomic mass of silicon, which is 28.1 AMU. All right, the most abundant isotope. Generally, the most stable isotope exists as the one in the highest abundance. So let's back up a little bit. We said here, silicon 28 was 92.23% of all the isotopes that exist for silicon. So this would be the most stable version. Backing up to the other problem we had, we said out of cesium 133 was 75% of the time is the one that you find. So that would be the most stable isotope. Okay. And it, of course, contributes most to the atomic mass because your percentage number is higher, so that's going to give you a larger chunk of that mass number that's going to contribute to the average. All right, checks for understanding. Let's look at this. Now, C12 and C13 are naturally occurring isotopes for the element carbon. C12 occurs 98.89%. Again, so carbon 12 is the one that makes up the most of your average atomic mass. And C13 occurs only 1.108%. What calculation should be used to determine the atomic mass of the element? So really, they just want, what's your formula going to look like when you fill in the numbers? Which one would be the correct one? And hopefully you chose letter H. Okay, these two look almost identical, except for you got to be careful. You got a minus sign here, you got a plus sign there. We want to add them together, so it's H. Next one, the element chlorine exists as 2 naturally occurring isotopes, Cl35, which occurs 75% of the time, and Cl37, which occurs 25% of the time. Which of the following calculations should be used to calculate the correct average atomic mass of chlorine? Same type of question. You're just trying to figure out which one would be the appropriate way to set it up. And hopefully you answered letter A would be the correct answer. All right, the atomic mass of an element is weighted. Is the weighted average of atomic masses of? Let me read that one more time. I kind of messed that up. The atomic mass of an element is the weighted average of the atomic masses of, would they be the least abundant isotopes of the element, the naturally occurring isotopes of the element, the artificially produced isotopes of the element, or the natural and artificial isotopes of an element? We didn't mention anything about artificial. And what do we say about, how much? We said it was pretty much kind of like all of them, because we had ones that were 5%, we had 75%. So it doesn't have to do with least abundant, it has to do with all the isotopes. So number 2 would be the correct answer. It's just the naturally occurring isotopes of an element. It includes the least abundant, it includes the most abundant, it includes the ones in between, because that's why you got your percentages. Okay, so number 2 is the correct answer for that one. Okay, guys, that's what I got for section 3 of our average atomic mass section for unit 2 of chemistry. So hopefully if you have any questions, I will hear from you. Have a wonderful day.